uh, is all set. So let me just reintroduce myself and welcome you all to today's session, Supercharging Your Data Science Workflows. My name is Alex, and I'm going to be your MC for today. So just one moment before we kick off this session, I just wanted to go over some housekeeping rules first. As you can see, mics and videos are going to be disabled for attendees today. However, this is meant to be an engaging session, so you can direct any questions you might have to the chat that is open. As Manu is presenting, we may not be able to read all of the current questions coming in, so just please be patient and we will ensure we save some time at the end to answer any unanswered ones. Lastly, a follow-up email is going to be sent out with today's recording, as well as a quick post-webinar survey that you're going to get from Zoom. You're going to have a chance to win some discounts on training upon submission, so I wanted to call that out. And one more thing is that Manu has actually put together a really great supporting resource document, that I'm going to share in the post follow-up email. Now, with that said, I just wanted to really briefly go over Ascendient Learning as a company. So chances are you might have purchased a class or program with one of our 3 legacies in the past: Accelerate, ExitCertified, or WebAge solutions. The collection of these 3 brands is now actually known as Ascendient Learning, what you see today. But our mission remains the same. We're still dedicated to providing a full suite of services and resources to assist the entire life cycle of employee technical training. We can provide IT training that covers a spectrum of organizational needs at every skill level. We offer vendor authorized training with vendors like AWS, Microsoft, NVIDIA, and more for individuals. We also offer customized courses for teams that can be developed to accomplish project end goals. And we even offer specialized programs tailored to organizations at scale. In addition to that training that we offer, we also have a really large library of resources, much like today's webinar. We do tend to see requests asking to run the sessions internally for their organization, which we can certainly do. It's a really great resource and really the first step towards learning about AI and data science and the ways you can take advantage of it for you and your team. So if that's something that you may be interested in for you or your team, I'll share some contact info in the chat where we can get you in touch with one of our instructors to discuss that further. But with that said, I am going to introduce our instructor for today running this session, Manu. Manu is actually one of our technical instructors at Ascendient Learning and actually teaches primarily AI, ML, and data science. He's been in AI and data science actually for over 10 years, starting his journey in AI around the time of the Watson rave, if I am correct, excuse me. In the past 5 or so years, as GenAI has trended upwards, we've actually been dedicating to creating generative AI classes and programs that sort of reflect those constant changes. And Manu has actually been one of our core instructors and pivotal in creating most of our GenAI course content. So no better person to lead us on this journey today for our session. So with that, I'm going to pass it over to the expert for today's class, Manu.
Awesome. Thanks so much, Alex. Let me go ahead and share my screen. All right. You confirm that you see my screen? You can give me a thumbs up. Are we good? All right, cool. Perfect. Awesome. Well, welcome everyone. Thanks so much for joining. Super excited to deliver this webinar to you all. I know we have a bunch of people online from probably all over the world, across many different industries and verticals, and really excited to bring this to you all, representing Ascendient. Okay, so the goal of today is to learn how we can harness generative AI in order to supercharge your data science workflows. We're going to talk a little bit about how generative AI has been changing this landscape in a global, broad industrial sense, but then also zoom in specifically how generative AI can transform data science frameworks and workflows. We're going to show you some LLM tools for advanced data analysis and various different types of data science capabilities that we can let's say, Supercharge with large language models. We're going to showcase and also showcase you some demos for collaborative data science coding, and then also highlight some real world industry applications and examples, and facilitate, hopefully, through all of the folks here, an interactive discussion on challenges and opportunities. So speaking of interactive discussion, I love to see comments and responses in the chat. So please go ahead and feel free to drop your emojis in the chat, drop your thoughts and your questions, and we'll try to take the questions at least as we go, probably in batches, but the comments are always welcome. I'm monitoring the chat as always. A little bit about me. My background is in data science and AI. Like Alex mentioned, I give people kind of a funny story or an analogy to think about it. It's like I've been sitting on a park bench for a long time, for over 10 years, and no one really cared what I was doing or what I was up to. I was on a park bench sitting, that was called AI, machine learning, and no one really cared. And all of a sudden, everyone seems to be really interested. It's like there's a parade going through the park, and all of a sudden people are so interested. Hey, what have you been doing on this park bench for all this time? Tell me a little bit about what you do. I actually care now. So it's kind of a really interesting time to be alive, doing what I've been doing, but continuing to expand and go deeper into how we can kind of make that bridge between human and machine or artificial intelligence. So really excited to bring this to you all. To get started today, I want to take a quote from someone who's become increasingly famous because, especially of NVIDIA stock prices, Jensen Huang, who actually got to see when I was in the Bay Area doing an NVIDIA certification training. So he mentioned something that I really like. AI will be the most transformative technology of the 21st century. It will affect every industry and aspect of our lives. And, one could consider that maybe this is bias from the CEO of the largest chip manufacturer in the world, but I really don't think it's too overstated because I have lived this process already in my own work, in my own day-to-day. And I'm talking about not just using AI for coding. I'm talking about, I wake up and my wife asks me, hey, can you make a salsa or a sauce for, this chicken pigetti or whatever that she's making? And I say, okay, ChatGPT, help me figure out the best way to create a sauce. And, it's on our phones, we're plugged in, and I use it all the time. In fact, I have to force myself to take space from AI. But for the last couple of years, I've been eating, sleeping, breathing AI, and I really love it. It's a way to interact with the world and to interact with a synthesis of human knowledge and intelligence that is never been matched before in the history of humanity. And I think that's really impressive and interesting and exciting. We will talk about some other aspects of this, but I wanted to kind of get us thinking about how we can begin to leverage generative AI. Now, I'm sure that many of us, myself included, have just become inundated in our social media, LinkedIn, email chains, etc., with there's an AI tool for this, there's an AI tool for that. There's many different AI tools for every single thing that you could think of, right? This is a little bit like the app craze from, I guess, was it maybe a decade or 2 decades ago when the iPhone came out and the App Store released, and all of a sudden there's an app for this, there's an app for that, right? And I actually had a blog article about this that was basically riffing off of that whatever you think of, there is an AI app for that, right? So it can be a little bit overwhelming, even if, for example, someone is a data scientist or machine learning expert. And I've talked to folks who already are veterans like myself with 10 years of experience in AI. And even for us, it's overwhelming the amount of information coming through, the amount of tools, technologies, and advancements. It's at a blinding pace. And so one of the things that I try to do in my classes that I also hope to do in this webinar is to see if we can kind of distill the core principles, the core ideas, the most useful things that we can take back in a grounded way and implement in really practical way within our organizations, within our data science teams. And I think that is really, my goal in this webinar. If you walk away from this webinar and you are able to have a better grasp of not just terminology and trends, but beyond that, have a deeper intuition for what we can do with generative AI, and especially what we can do with generative AI in the field of data science, then I'm going to call today's webinar a win. All right, so that's my goal for today, and also for us to have fun along the way, and to enjoy each other's company. All right, so we're going to start off by setting the stage for AI's role in data science, talking a little bit about current trends. We'll do some demos. We'll talk about case studies. And all of these, it's a little bit like a sequence of how the webinar is going to go, but also all of these things are interwoven throughout each aspect as we move forward through the webinar, right? And the last one, industry discussion, this is going to rely a little bit on you all, for you all to share some of the things that you've been seeing on the ground, some of the things that you're interested in, some of the challenges that you're facing. And I'd love to hear that feedback. We're going to do a couple polls actually coming up right now. We're going to do one poll coming up and a couple more polls. But also probably will ask some questions, and feel free to respond in the chat. And the more people that respond, the better idea that we can have, and we can learn from one another, right? So this webinar is not just, this is me teaching you, but it's also an opportunity for us to come together based on a topic of mutual interest that we can connect about and that we can all learn from one another. All right, so that's the way I like to run my classes and webinars. So let's dive into, I always like to start with the why, right? Starting with first principles. Why does this matter, right? Beyond the hype, beyond what everyone has been probably undoubtedly talking about. Everyone wants to get in on the generative AI parade. But let's talk about some actual statistics, right? So 65% of organizations have already started using generative AI. And this generative AI adoption has surged 17% just from 2023 to 2024, and I expect that it's going to shift even more as we really roll into 2025. I mean, I guess you could say we're past Q1, so we're well rolling into 2025 already. But I believe that we're going to continue to see an increase in adoption, and not only are we going to see that on the enterprise side, we're also going to see that the consumers are also going to be more comfortable with AI-based solutions, with AI-based let's say artifacts or AI-based services. And that's also going to drive adoption both in the enterprise and consumer sector, right? So the market projects, and I've heard different numbers all over. So, this is just one number. You may have heard a different number, but I'll share one number that I saw that was cool, but that was interesting from this McKinsey report, that the market is projected to reach about 1.8 trillion by 2030, doubling market size every 2 years, right? So we're talking about almost like the new Moore's Law. If you know what Moore's Law is, which is about the doubling of transistors every 2 years, right? We're seeing something very similar in the AI space. And I think that we're going to continue to see that in the coming decade or more. And 67% of organizations expect to actually increase their investment in AI over the next 3 years. And so all of these statistics for me spell a couple of things. Number one, we see that generative AI is on the rise and it's here to stay. There is a lot of folks that talk about the hype cycle, and this is just another hype cycle wave of technology. And to a certain extent, I do agree with that. But on the other hand, when you talk to other AI experts, and it's this leap is so pivotal. It's almost something like when smartphones came out or when the internet came out. This is something that's going to become a what's the word I'm looking for? It's going to become an integral part of our daily lives. And so I believe that generative AI is here to stay. And it may not be the last wave of AI, right? We don't know what we don't know, and we don't know what's going to come next, especially in the field of AI, where there's so many changes happening. But we do know that we are going to see a massive shift, and that is at least worth investing our time, like you're doing here right now, to learn about this, to get familiar with this, to get ahead of the curve, or if not even ahead of the curve, to get on the curve, right? So that's a little bit about why generative AI, right? So research suggests that generative AI is transforming many fields, including software engineering, data science, even things like supply chain production, with trends like agentic AI and small language models, especially in 2025. Right. So these are some trends that I'll talk about and highlight, and we'll see how much of it we can demo as well. So tools, everyone's heard of ChatGPT. Probably you've heard of that before you came on this call, right? But tools like ChatGPT, Copilot, Replit, which is another one that I'll demo today, they're allowing us to enhance our capabilities to perform data analysis and the productivity in cranking out code, right? So the evidence kind of points towards real world applications in industries all across the board. I gave a couple here that I'll show in case studies as well: healthcare, agriculture, construction, of course, in the technology field, software engineering, obviously, but so many other industries that may not necessarily, let's call it, the most technically averse, or the technically versed. That's the word I meant to say. There are many different industries that may not be, incredibly technically versed, are going to see transformation undoubtedly, right? Because of the real economic pressure, where if one person is able to do more with less of a human workforce and less cost, then that company or that organization within that specific vertical is going to be able to outcompete every other organization within that same vertical. So this is one reason that I like to call this whole, competitive space nowadays, the AI arms race, right? So I think there's certainly a lot of market pressure about adopting generative AI. And one of the things that, I've talked to certain, I think is really interesting is that, in the past, when I was, let's say, data scientist or AI engineer, and I wanted to use a new tool or do this fancy shiny new toy technology thing, we would get a lot of pushback from business stakeholders and leadership. And now the pressure is reversed. The pressure is really coming top down that, hey, when are we getting generative AI on our platform or our website, our internal systems, right? And what do we need? And the data scientists and engineers say, hey, wait, we have to look at the safety. We need to make sure that we really have it together. And so, by the way, if you have any thoughts on anything that I'm saying at any time, feel free, please drop it in the chat. I'd love to hear your thoughts as we go along here. All right. Cool. So these are some of the trends that we're seeing in 2025, and it's a really pivotal moment for this field, right? Because the interest is there, the adoption is already starting to stabilize and really kick in, get rooted in generative AI. But I think that a lot of us may be wondering, but what about all of the technologies that existed already, right? What about, just good old fashioned machine learning on a CSV document, or machine learning on my database, machine learning pipelines, and our ML ops infrastructure? Does that all have to go in the garbage bin? And what does it even mean to, bake in generative AI into this workflow? And I think that's when I talk to companies of all different sectors, one of the key things that I see that is a little bit of a roadblock beyond, of course, the let's say the fears or the cautionary tales about security risks and privacy concerns. One of the other key things that I see is just really this overwhelming challenge of, look, we already spent maybe billions of dollars figuring out the last machine learning wave, and finally, now that it's just stabilized and we have all of our scripts that are able to work with database and pull database schemas and all this stuff, and now we have this generative AI thing, and we need to integrate this. How is this going to integrate with the things that we already have? How does this fit together? How do the puzzle pieces come together? So I'm hoping that through today's talk, you're going to get a little bit more clarity, and also get to see that generative AI is not necessarily going to replace everything that existed before. And in fact, done well, it should complement and enhance everything that already exists within your organization's portfolio. All right. So we'll do some hands-on demos and talk about case studies like I mentioned. But first, we're going to do a quick poll. So Alex, would you be able to post boom, she's on it. All right. So there we go. We have a poll, if y'all wouldn't mind taking a moment to answer that. And the question is, which generative AI capability presents the most significant transformation opportunity for your data science workflows? So I'm really curious. I would love it if everyone could participate in this one. Let's see what people think. All right, we got two of them. They're kind of neck and neck. Wait for maybe 10 more seconds. All right, I think we can call it. Let's see what the results look like. All right, hopefully everyone's seeing the results now. So it was neck and neck between three of them, really: automated feature engineering and selection, code generation and optimization, and data pipeline automation and maintenance. Now, was there something that you are potentially seeing as a significant transformation opportunity that wasn't in the choices? Please go ahead and drop it in the chat. I would be curious to see. These are just some of the things that I thought about. But I would be curious to see what other folks are interested in or thinking about as well. This is something that, that's how I learn as well, right? I learn from folks in the industry what is going on in the market. So I would love to learn from you all what you think about significant transformation opportunities. So the top one is code generation optimization. Amazing. I have a ton of stuff I can share about that with you all. We will talk extensively about that. One of my favorites on that subject is the tool Replit, which I'll demo today. We will also talk about data pipeline automation and maintenance, and I can show you a little bit about that. And I can work in also some demo about automated feature engineering and selection. So let me actually just I'm going to take a screenshot of that poll just so that I have it here. There we go. All right, cool. So let's go on. I like to see those so that we can inform the things as we proceed. Now, here's the challenge, right? One of the biggest challenges that I see with many modern organizations being able to roll out or leverage generative AI is the structure of enterprise data. And I'm not even just talking about unstructured data, right? Because many of you may know that generative AI is useful for unstructured data. So this image is not necessarily, it can represent to some extent the challenge of unstructured data. But one of the other things that I think is really useful is to think about it as the fact that a lot of data pipelines and data lakes are kind of like a little bit like a house of cards. And we could extend that depending on the organization or one's personal opinion. And this is not to chastise anybody, but just to say from my own experience in the corporate world, and also from day in, day out talking to folks in the industry, is that a lot of times one of the things we tend to see in enterprise is that it's built like a house of cards, right? So for those of you who don't know that idiom or analogy, I'm not talking about the Netflix series, which is, by the way, it's a great Netflix series, at least at the beginning part of it. What I'm talking about when I say house of cards is that if I remove one card or if one piece breaks, the entire thing can fail, right? And there's definitely a lot of potential, there's a lot of different ways that we could leverage the existing technologies that are out there to help mitigate that or minimize that. However, one of the key challenges to really adopting any type of AI solution, and I'm talking even predictive AI, the classical AI, or generative AI, is the fact that the data pipeline can be quite messy. And by messy, I don't just mean that the data is not clean. I also mean that the pipeline itself can be brittle, that it can easily break. One thing breaks, the senior engineer goes on vacation, and all heck breaks loose. So this is something that we have to consider as a key pain point. And from surveying many different people, this is one thing that I tend to see. Okay, so the generative AI landscape, what can it do for us? I mean, we're going to talk about what generative AI does, but essentially generative AI is a branch of AI that creates new samples based on learned patterns in data, right? And the way it does that is by learning the underlying distributions of that data. For those of statistics nerds out there, it does that by learning the cumulative distribution function, as opposed to in standard AI, traditional AI, where we're looking at conditional probability states. And by learning that underlying distribution, we basically build a representational map of that data space. This is what embeddings are, for those of you who have heard of that. And by building that representation, we have the actual capacity to build new samples, right? This is why I can, for example, now go on ChatGPT and say, hey, show me an image of a dog riding a skateboard. Well, actually, there might be videos out there of a dog riding a skateboard, but I could, take two things that are completely different and seemingly, irrelevant to one another, but I could have generative AI find a way to bridge that gap, right? It may hallucinate, right? But the idea is that because it learns so much from one space and so much from another space, and each of the concept spaces around each of those words that I put into a prompt or an input, for example, to a model, it's able to pull together those things and generate something new. So that's why we call it generative AI, because it's able to generate new sample data. And I'm not just talking about, generate new data in the sense of synthetic data augmentation, but I mean that it is fundamentally or functionally different than the traditional AI, where let's say we're doing something like classification. We're predicting, is this credit card fraud or not? What is the stock price or the sales forecast going to look based on XYZ set of parameters that exist in the CSV table, right? The idea is going beyond the capacity to, let's say, fundamentally predict a category or predict a quantitative value. We're actually able to create new data that is representative of the data we were trained on, or queries of interest, right? So that's at a very high level, that's my elevator cocktail party pitch of what generative AI does, right, in a relatively non-technical way. And there's many different applications, and they go much beyond actually just text generation and image creation, or even music composition, code generation. But there's so much more, right? Because one of the things that generative AI really unlocked, that I want us to be thinking about, is that it unlocked our ability to interface machines with unstructured data types. Now, what is unstructured data? Unstructured data is stuff that doesn't sit in a CSV table or a database table, something you access with a SQL query or with directly with Python, right? Unstructured data is like the conversation that we're having right now, like the transcript of the webinar that is going to get generated, right? So these are the types of thing, or images or videos, right? These are all things that are, probably for humans, like a fundamental part of our experience. And I think that's one of the reasons there's so much excitement behind generative AI. It allows us to have even more reach with our reality, right? With the what our senses perceive, what, audio, video, right? We're able to get more into what we're actually already living and experiencing as humans, that up to now only the brain was capable of processing those things, but now we're building the capacity for machines to interface with those things. So I think that's really exciting. That's really interesting. And I think that many humans, and myself included, have an innate curiosity about a machine that can help us make sense of our world. Okay, so we can consider that generative AI is a little bit like an evolution in technology from traditional data science, and I also include in that bucket traditional AI, right? And this image is not to make fun of traditional data scientists. Remember, I came from traditional data science, right? So it's not if you are an expert data scientist without knowing generative AI, I'm not saying that you have cobwebs around, hanging off of you, right? Instead, what I mean to suggest with this image is to say that there is an evolution in technology and a massive difference, or a leap, from what we had before to what we're moving towards. And traditional data science and AI, like I mentioned before, still has a space in the industry. And in fact, in some cases, it still might be the best solution. I can't tell you how many times people have come to me and said, hey, Manu, so I have this use case for generative AI. And I said, okay, what's the use case? And I listened very patiently, right? And they tell me, yeah, so we have this CSV, we have this use case, and and we have the CSV, and we're trying to predict this. And I pause and I ask them, okay, can you tell me why you're specifically interested in using generative AI for that use case? And they say, well, I mean, that's the newest tool. Yeah, we want to make sure that we're using the latest technology in order to be able to deliver this use case. And I say, okay, so let's back up for a second, because traditional data science that works well with CSVs, databases, et cetera, or let's say works natively with those structured data elements, it still has a place. right? And in some cases, those folks haven't even explored traditional ML methods. And in other cases, they just want to have the newest of the newest, and they haven't realized necessarily that generative AI really works better when you have a type of unstructured database, some type of unstructured database that's there. So let's take an example, right? So if I'm just, again, pulling one off the top of my head, but I'm curious to hear. Actually, Zona had mentioned marketing and research purposes. That's a perfect example. Okay, so if I have a CSV of customer information, okay, and this contains things like the name, the age, the all of the demographic information of my customers, how much they've purchased, when they purchased, and all that stuff that sits very nicely in a CSV. Okay, and now I want to use generative AI, but in order to use generative AI, I would need to provide it some type of text. Well, I could provide it the table, and I'll show you a little bit later how we can use something like ChatGPT in order to go ahead and analyze that database. But what the generative AI, the ChatGPT in that case is doing is it's not reading the database as such, but it's getting enough information about the database in order to be able to generate code, right? It's not generating a database, it's generating the code in order to be able to analyze and visualize the database that you have, right? So it's important to, kind of make that switch that generative AI is, at least, I've seen some other workarounds. And so I'm not saying this as 100% this is how it is, but, people have reverse engineered some nifty tricks and ways in order for generative AI to work with various types of structured data. I'm not saying that doesn't exist. It does. And I'll show you some of those things. But what I really mean to say is that we have to, on a first principle, basic level, understand that generative AI works primarily or on a native basis with unstructured data, right? So let's take that same type of marketing data, but what if I have marketing reviews, right? I have reviews of products from those customers of a certain customer ID who are my top spenders, right? That's different. That's a perfect ball game for generative AI to go through all of those reviews, read those reviews, categorize those reviews, and do a whole bunch of things, all to your heart's content. But that's different than plopping a CSV and expecting that it's going to necessarily directly read those things. You can pop it into a data analysis tool that uses generative AI to write the code and build images, for example. Right. So, and I'll show you some of that. But again, if anyone has any questions on the things that I'm talking about, if I'm going too fast, I'm passionate about this stuff, and I've had a little bit of coffee today, and I just got some more coffee here. So just let me know if I'm going too fast. But excited to get to the demo. So that's why I want to get through, at least the lecture a bit. So, because I think that, when people see the tools in action, you're able to just absorb so much more. All right. So that being said, right, like I said, traditional data science still has a space. So which approach should we use for our data tasks? Knowing that traditional data science has a valuable place in the industry and the generative AI can work hand in hand with traditional tools as well, right? How do we navigate this space, right? So traditional data science typically focuses on structured data, statistical models, improved business decisions through explainable insights, right? It's kind of like the classical traditional data science. Generative AI, on the other hand, excels in being able to create content from unstructured data, and even in some cases, putting structure to unstructured data. For example, I'll show you today, if we have time, Llama Cloud, which is a nice nifty tool that allows you to, for example, create a structured JSON from a massive unstructured PDF document, for example, of a 10K filing, right? So it really is going to depend on what type of data. So what I tell people, if you want a quick litmus test to know, which one should I use, ask yourself what type of data it is. Ask yourself what type of data it is and what is the use case that I need it for, right? If the data is unstructured data, if there's written text in there, written text that might require a human to go through and read a bunch of things, right? That's different. If the data that you have is structured and the task is something like where a person is sitting there with Excel or Python pandas and they're filtering rows and they're creating visualizations, right? Generative AI can automate some of those things for you, but at the end of the day, it's probably still going to, at a paradigm level, still be focused more or less on traditional data science or predictive AI, as I've been mentioning it. Okay. So traditional data science versus generative AI, typically the traditional data science is a pipeline driven approach. There is some benefit to that in generative AI as well. So there's a bit of overlap, right? However, generative AI tends to be a little bit more open-ended and dynamic because, and we see this in security, for example, right? When we are trying to protect an ML model from hackers or threat actors, the challenge is quite different compared to protecting an LLM-based application or a generative AI application in cybersecurity, because the attack vector massively increases, because a person can do prompt engineering or prompt injection and do all sorts of things in order to be able to get access to core data or things within the LLM's directory. So that's probably the dark side, right? But in the generative AI sense, we typically are thinking more about a creative approach in some ways, creative content generation. I don't mean creative in the sense of, oh, I'm creating art and images and music. Yes, you can do those things, but I'm talking about even in business, the creative ability to create something new. The reason for the adjective generative, that's really what I'm talking about when I use the word creative and creativity here. And it has an unstructured data focus, whereas traditional data science, really focuses on structured data and statistical models. Now, fun fact, generative AI still has to operate on statistics and probability. The way that the words are getting generated word by word by word, when you give an input prompt to a system, for example, is based on a set of probabilities that are being navigated, and words are being selected based on their probabilities. Right, so probability is still at play in generative AI. It's a little bit more subtle. It's a little more baked in, but it's different than in traditional data science where you're going to do a p-test, or in a time series data you're going to run ARIMA, and it's quite different in terms of a paradigm. And this is really important to consider, because there's a lot of data scientists that I often talk to that, for example, they're used to, okay, well, I get some data and I train it. If I have new data and I want my model to be able to understand things about the new data, then I have to train my model with that data. And people assume that that's the same in generative AI. And to a certain extent, there is some relevance of that, but it's not necessarily the same. Because, for example, in generative AI, the models are so massive, so large, gigabytes and gigabytes in some cases, that I tell people 99.9% of people in every organization in the world are not going to be able to, or not only not going to be able to, or not willing to go through the headache of spending $10 million just to train a model, right? When there's already that model that exists in both open source and pay-as-you-go commercial services with a simple API call, right? So it makes more sense, instead of building a bike from scratch, soldering the aluminum and so making the spokes for the wheels from scratch with deep learning and PyTorch, and instead a little bit easier to just learn how to ride the bike, learn how to be able to leverage and use the LLM models, and in some cases retrain or fine tune a portion of the models. So there are some caveats and misconceptions that exist even for veteran data scientists and ML engineers that should be re-examined from a first principles approach in order to be able to make the leap for the next wave of AI. Okay. This is a good pause point to see if anyone has any questions in the chat. Anyone have any questions? Yeah, please feel free to share questions at any point throughout the session. And we are monitoring the chat, right? So how do large language models power generative AI? So large language models are a type of AI model that generate text and unstructured data using a deep representation of that data, right? So you'll have input text and it goes through various layers. I don't need to get into the technical details of how it happens for the purpose of this talk, but it's there, tokenization. And the analogy that I use for people is that it's a little bit like when you go to dinner, you have a nice meal, right? Or really any meal, even if you're chowing down a cup of noodles at the airport, right? When you eat something, right, you're chewing. The first thing you have to do is you have to chew that information, right? Because food is information. You have to chew that information. It has to get broken down into small bits. And once it gets broken down to small bits, it moves a little bit further down the chain, and then it gets broken down into smaller bits, even still by the pepsin and the other enzymes in your stomach. It gets broken down further at molecular level, and then it goes further down the digestive tract, right? So and analogously, there's a very common term called data ingestion, right? Which is the process about taking in data and formatting it and processing it and cleaning it, right? So in a very similar way, in the process of training large language models, there is a process of taking a piece of data and breaking it up into words and subwords in order to create like a vocabulary. And from that vocabulary, we create a type of mental model or a mathematical model that allows us to be able to navigate the space of language or images or audio, whatever type of data we're working with. And then we can get to the part of prediction or generation, where we actually can, let's say, create the next word or predict a word or generate text. Right. So this is a very, very high level overview, right? Remember, I teach like a full 5-day course, 8 hours a day for 5 days, right? We teach several programs as well in generative AI. So in those programs, we go into much more depth about what actually goes on in the core fundamental technology of large language models and transformers, if you've heard of that architecture. But this is a high level understanding for most folks. So key 2025 trends, I mentioned this a little bit, but I'm coming back to it. Agentic AI, probably every one of us has at least heard the term agentic AI. If you're interested in this talk, you came here, you've already heard about agents. I almost guarantee it, right? So agentic AI are AI systems that perform tasks independently through automation tools, or they allow us to automate various processes. Because one of the ways that oh, great. Thanks. We got a question. I'm going to get to that, get to your question in just a sec, David. So one of the ways that agentic AI works is that if we consider that the goal of most AI systems is something called goal-directed adaptive behavior, right? It's like a 4-word description of what AI can do. Goal-directed adaptive behavior, right? Being able to behave in such a way while adapting to circumstances in order to reach or meet some objective or goal, right? So what agentic AI can do, for example, is that it allows us to reduce the level of human interactivity required, or coaching, or back and forth and hand holding, so that it can do more on its own. Really, that's what I think about when I think about agentic AI. And actually, even the phrase agentic is still coagulating. It's still not a solid one and done, AI agent. So when people talk about AI agents, just know that it's not as limited or refined as something like retrieval augmented generation, or as something like ETL, right? That means this one thing, right? The definition itself of what it means to be agentic is still coagulating in the field. Okay, so there's many people claiming everything. We have agentic AI here. We're doing this with agentic AI, but one has, especially if you're technical, one has to kind of go through the mud in order to see which technologies are the most useful, the most innovative, the most valuable. Okay, now another one on the other side, we have small language models. One of the things that I talk to people about is that there's kind of two forces. You may have heard about this thing about, Google's releasing this 1.5 trillion parameter model. Hugging Face released XYZ parameter model, DeepSeek, etc. Right? All of these model names that get thrown about, and even on CNBC, you see it on the news that it's affecting stock prices and the like, right? But what does that mean, the number of parameters? The number of parameters, what it means is the number of elements, to put it lightly, the number of elements in the neural network, the essential engine that powers the LLM, the architecture of the LLM, the number of elements in this train. Just the way that our neural network, our brain, is made up of a bunch of neurons, right? Those neurons are elements, and those neurons in and of themselves have sub-elements like the dendrites and the axons, right? So in the same way, the neural network in the machine, right, has various elements, and it's taken across the whole entire network. We have, let's say, a number of parameters, and those number of parameters are configurable numbers that we use as a type of, let's say, prediction mechanism in order to be able to train and learn a space. Remember, we talked about earlier about how generative AI works. In fact, all AI works by learning some type of distribution, some type of data distribution, by learning some data. So the neural network, just like our brain, right? I have a kid, he's very young, less than 2 years old, 1.5 years old, let's say. And it's amazing to see how he learns, right? He came in with a brain and he started seeing things. He starts learning words. He learned to walk. Now he's learning to run. And it's amazing to see how the human brain learns. And we, in a sense, had to reverse engineer our own brain, but it was actually a very difficult problem that took us thousands of years to figure out how to do, right? So the number of parameters that a certain model has can be massive amounts, like 1.5 trillion or in the 7 billion up. That's a relatively large language model. Now, this idea of small language models is something that's been coming out more recently, which is kind of the opposite spectrum. As on one hand, companies like OpenAI, Google, Anthropic, you name it, they're trying to create more and more complex models that are the cutting edge, state of the art. On the other hand, you have companies like Apple that are trying to create functional models of a similar technology, but on the other end of the spectrum, so that they can be loaded on your phone. They can be loaded on your phone, and they're light and small enough to be able to run offline as needed in order for you to be able to do what you want to do and stay with AI even when you're on airplane mode for on a plane, for example, right? So that's the example of small language models. And combine that with things like technologies like the Internet of Things, you are going to see that small language models is really going to lead to the penetration of AI throughout the market in all different facets of life. So that's one reason that was a whole spiel about why small language models are useful. I went more into depth about that than I thought I would, but that's okay. So skipping through rolling through the rest of them, data quality and unstructured data. So being able to manage unstructured data is super crucial, and this is vital to how generative AI operates. I think we've already covered that one. Multimodal models. Multimodal models is basically very simple. The idea that the AI model doesn't only work on text, but that it can work on text, images, and videos all at the same time. For example, imagine that I work at a financial company and I have the ability to upload checks, right? Most of us have a bank app of some sort of on our phone where we can upload an image of a check and do mobile deposit, right? Well, what if I wanted to not just do the mobile deposit and transcribe all the handwritten characters on there, which is one useful thing now that can be done with generative AI as well. But also I want to be able to check that and match that with fraud, or I want to be able to, look at the combination somehow of images and video along with text. One of the really funny, famous ones was creating a meme generator, which turned out to be relatively challenging because for a long time, ChatGPT, for example, had Dolly, but that Dolly nor Midjourney were able to really create text that went well with a certain image or a caption that was able to be on top of the image. So that's an example where a multimodal model was used in order to be able to kind of align the realms of text and image. But you can do that the same with audio, video, etc. So whenever you have something that can take multiple types of information, right, in multiple realms or multiple types of media, that's a multimodal model. And actually, multimodal AI was one of the things that was really taking off and was kind of reaching a peak just before generative AI really took storm, and then generative AI really took over. But then multimodal kind of made a comeback through the lens of generative AI as well. So this is one of the interesting trends in the industry that's happened recently in, let's say, the last 5 years. So what are the key approaches that we can take for generative AI? One of them is prompt engineering, which is essentially how do I form what I put into the chat box, for example, at a simple level, but also at a programmatic level when I'm actually writing generative AI applications. What are the types of system instructions or developer instructions that I provide to my AI model that allow me to be able to make sure that it behaves in the way that we want it to behave, right? The famous example of the Chevy dealership where there was someone that went viral because he posted how he did some prompt engineering, prompt hacking in order to be able to get the AI, which was really a representative of the company, to say, yes, I'll sell you a Chevy Tahoe for $1. And that's a legally binding offer, right? So of course, I don't think the guy actually ended up getting the Chevy Tahoe, but it shows some interesting aspects of prompt engineering on both sides. On the one side of how threat actors or people want to exploit your application or your organization can use prompt engineering, and on the other side, how if there had been a little bit more clarity and a little bit more preparation and caution in rolling out that tool, then and guardrails, a lot of things could have been avoided. So that's the one case of one of the key approaches, which I would say is the fundamental thing. So if your team, for example, wants to get into generative AI and they need to learn one approach, the first one I recommend everyone learn is prompt engineering. Okay. And there's a lot of nuance to that. I mean, and prompt engineering is not just about learning about these terms like chain of thought and tree of thought and least to most and all the terms that come out in research, but actually prompt engineering for me is the art and science of communicating with AI. And that involves practice. It involves practicing again and again and again and seeing how this machine that doesn't think like a human responds to requests by a human based on a human context, and how we can kind of learn to work better. The thing that I tell people with prompt engineering is that it's almost like if you just hired and you hire, let's say, a secretary or an intern, and you have to walk them through step by step about every single thing. Here's where the cafeteria is. Here's where this is. This is the time that we go to the cafeteria for lunch. This is how we do the email. This is how you submit your invoices and billing out, etc. Right? So in the same way, the more didactic and specific we can be while we communicate with large language models, generally is going to yield better results, right? Including specific instructions to prevent misuse. All right, retrieval augmented generation. So this one was one of the ones that came out a little bit after prompt engineering. It was kind of the middle of the road since the beginning of the generative AI boom. And I'm sorry, I forgot to answer David's question. So thanks, whoever telepathically communicated that to me. So David had asked a question that said, I came across an article of data poisoning. How is data cleaned for the LLM? Well, that depends, right? So if you're building it on your own, then there's any number of tools that you can use. And how much data cleaning is done actually for these massive models generated by OpenAI and GPT-4, it's actually unclear to me, because actually a lot of companies remain very, very secretive as to what it is that they actually do with the data and even where they get the data from. So a lot of those things are kept very hush-hush, but there's some people who, of course, publish more about that in relation to open source models and open weight models. And I would say that the key things to consider is that it's a little bit different. Like if you're familiar, for example, with the traditional LP paradigm, we don't need to do anymore the types of things like stemming and lemmatization, where we have to process all the text and chop off all the suffixes in the words and do all this stuff, right? All we need to do is run it through a certain tokenizer and consider that the tokenizer itself is appropriately useful for whatever task that I'm interested in. For example, code generation requires certain types of special tokenizers that'll recognize white space, and the tokenizer is really the part that does the parsing and primary conversion from text to a mathematical representation. Now, in terms of data poisoning itself, data poisoning is when, for example, someone has an application and they have some data and someone injects some, let's say, malicious data or false data or incorrect, erroneous data. And what that does is that it can bias the model in the incorrect way, right? So the approach for that one is to, of course, have a means to be able to monitor your data at a macroscopic level and to also be able to observe any types of changes and intrusions and things, including in some cases data deletion, right? So David, I don't know if that question helped, if that helped answer your question. I think that I understood your question properly, but please let me know. And sorry for the delay again. I got carried away. Hopefully that helped. Okay, so it's actually just in line with retrieval augmented generation, which is why it clicked for me that David asked that question. Retrieval augmented generation is the process of, well, how do we use generative AI with our own data, especially private enterprise data, right? Because one of the first things, as soon as generative AI came out and people saw ChatGPT, everyone was scratching their heads and saying, hey, wouldn't it be great if I could, put my whole computer on this, but without sending it publicly to the web, and have, like this type of chat interface, but for everything else I have, that's private, including enterprise data, right? So that is really where our retrieval augmented generation came from. It's the idea of how can we use large language models with a set of private data using the natural language reasoning ability of something like a large language model, but bridging that with the search capability of my own internal data set without publicly sending it or publicly training a large language model with that data. So that's really the core idea behind retrieval augmented generation. So anytime that a company is looking to, for example, build an internal knowledge management system, especially with regards to structured data, retrieval augmented generation is one of the first things you should look into. But again, you might still need to use some type of prompt engineering in that code. Fine-tuning is another one that is about actually retraining some of the models or a portion, a couple of layers of that neural network, and retraining that model to be able to modify those pre-trained models to suit specific tasks. This was kind of the rage before before RAG, retrieval augmented generation, but then people quickly realized it takes a ton of effort to train, it takes a long time, a lot of resources, and you can get most of the way with just prompt engineering and retrieval augmented generation. So people generally leave it as kind of a last case resort to try in case the other two don't work out. And then finally, agents, which is the newest wave, which allows the AI to be able to access tools, including accessing APIs, accessing other databases, accessing web search, and other types of functionality that were previously limited for an LLM alone in its ability, right? But remember ChatGPT, before it had the ability to do web search, for example. Once they included web search, they incorporated essentially some agentic elements in there. And then finally, multimodal, being able to have input and output data in multiple formats. I think this is still up and coming, and we're seeing more and more use cases on the rise. But this is still emerging. Emerging techniques, there's also things like state space models, which completely kind of go in a slightly different direction, let's say, than the traditional transformers architecture, and also obviously coordination between agents, LangGraph, and a lot of technologies that are coming out, as well as many automation tools, including things like vibe coding is trending right now, and I'll show you some of that on Replit in just a sec. All right. So this is a massive list of a bunch of different things. I'm not going to read all of this right now, but just at a high level, we're going to talk about ChatGPT and Replit. LangChain is a popular integration framework. Excuse me. Hugging Face has a lot of open source models that allow us to basically use freely downloadable LLMs. The problem is that you have to have enough data space or data storage or inferencing power like GPUs in order to be able to run a lot of those big ones. Google Colab and Jupyter Lab, which served as kind of playground areas to be able to work with, which I think most data scientists are probably already very familiar with. And then weights and biases, which was classically used to be able to monitor ML models in production, now has a lot of things for LLM monitoring, but there's a lot of other tools like Grafana and Prometheus and a ton of other, Langsmith, a ton of other tools out there in order to be able to track experiments and monitor LLMs just like you would with MLOps. But there are some nuances and some caveats. We're not going to get into all the details of that today, but it's just for us to know that these are some of the tools that are in the field. So generative AI can enhance data science, right? Traditional data science allows for basic decision support, but has a little bit limited task versatility and focuses mostly on analysis, right? Generative AI can enhance decision support because remember, it can allow us to be able to use natural language, right? So it can provide recommendations in natural language. It can read a chat transcript. And, here's an example of a use case that I've pitched before to people. Well, okay, you want to improve your call centers and your customer service. Okay, yes, customer service chatbot, sure, everyone has thought about that one. But what about the people that are actually on your customer service calls, right? The human beings that are there and they're looking, right? What if there's something that can actually, as the call is going on, which is being monitored anyway, that it can transcribe that information live in real time and provide suggestions based on a massive data set of information that the AI has to the customer services representative in order for them to be able to deal with the human customer, in some cases an angry customer, with greater ease, right? To be able to summarize the issues the customer has faced in the past, right? All these types of things are an example of how generative AI can greatly enhance decision support. So it has a lot of versatility and content creation capabilities. So, this is kind of the punchline that I want to get to, and then I want to switch and jump into a quick poll and some demos. With some of the ways that we can enhance productivity, right? I talked about a couple of tools, but the automation of data preparation and data cleaning. I think this is something that's very important based on what I just saw in the poll earlier, right? Being able to clean data. Well, how can we clean data, right, with generative AI? I'm going to show you that with the ChatGPT demo right now. How can we generate? I think most people are familiar already with generating code, but what is the latest, greatest versions of that, right? What is the best ways to do that? I'll show you some of that with Replit, where not only are you, typing with ChatGPT and it gives you back, Python code, which is 50% of the time very buggy, but instead, giving a prompt and it can build an entire full stack development app in one go, generating multiple files and testing those files iteratively by itself, testing that the code is actually working and proceeding that way, right? This is very popular in the kind of trending vibe coding right now. And it allows us to enhance, I don't know why this thing was cut off. I can't scroll, but sorry about that. So it can allow us to enhance communication with stakeholders, and also improved language summaries and internal knowledge management. It can also allow us to synthesize data sets, perform exploratory data analysis, and experiment and iterate, and actually reduce the cycle times that it takes for us to be able to work with our data sets, or to be able to analyze our data sets, even if we're using traditional data science workflows. Okay, so the automation of data preparation by with things like tedious data cleaning, the being able to generate at least boilerplate code snippets or SQL queries to accelerate prototyping, experimentation, rapid testing and refinement, summarizing and synthesizing complex findings or very large documents in a plain, simple language. This is especially useful in the legal domain, for example, right? GenAI can really act as a co-pilot, allowing data scientists to focus on strategic tasks using their human brain, which is massively more intelligent still, in my opinion, than artificial intelligence, to be able to really focus our creative capacities or intelligence capabilities towards more creative human uses, right? Which is, I think, what really makes all of us come alive and have fun, right? Pros and cons, right? The pros, I think we've already talked about extensively: automation, efficiency, multimodal analysis, accelerated insights. Some cons, there could be ethical concerns, right? What happens when the AI makes a mistake and that it has an impact on human lives or human infrastructure? It can be biased, right? A lot of people have this misconception that an AI is somehow necessarily more objective than a human being. And in some cases or versions, that's true. But also, if you understand how generative AI actually works, which is that it's based on a set of historical data that was created by humans, and it's taking a massive amount of that data. One of the things that can happen, ironically, is that generative AI can even amplify human biases. So it's something very important to be aware of. Okay, and also it requires a lot more overhead and data governance and really careful consideration. I think this will be reduced as we get more established in the field and things get to stabilize a little bit. So the road to Gen AI maturity, I think about 4 key phases. Can we speak AI? Can we communicate? Can we build AI applications? And can we tailor AI for our enterprise needs? And then can we create, produce, deploy, and maintain generative AI systems at scale, right? So think about these 4 phases, right? Can we speak AI is kind of like, have you mastered prompt engineering? Can you begin to use things like LangChain? Can you build applications using API-based calls to large language models? Then can you tailor AI for our enterprise needs? Can you do it a real POC that actually works for a real use case that has business value and improves ROI within your organization? And then finally, can you make this at a production level, right? So these are 4 phases, at least that I've highlighted or I've found across the industry as key phases of Gen AI maturity. So how do we create this roadmap? We need to assess the needs of what are the most high value use cases. Because when we want to start this whole process, let's say we're just getting started, the most important thing that I tell my clients and tell the people that I'm consulting with is identify the most high value use cases. If you don't know what that is, if you don't know how to identify those high value use cases, get help, right? But that is the key thing, right? There needs to be this type of cross collaboration between not just within the technical team, but also the technical team and the business stakeholders. Pilot projects, start small with GPT, right? And scale up. Adopt feature FTI pipelines, which is a word for feature train inference pipelines and auto scaling deployments, right? So scaling infrastructure, then govern and monitor the infrastructure that you've built, make sure that you've implemented ideally ethics from the ground up, right? Detect when the LLM models aren't behaving as expected, have alerts, have logs, and then iterate and expand and be able to roll out to new domains, right? So, but in order to do all of that, it's important to start first with the highest ROI use case. So why do human data scientists remain absolutely essential? This image is kind of this wise owl, which is representative of the human that is judging the AI and all the errors and stumbles that it has, right? So in order to have enhanced AI augmented business outcomes, we need to make sure that we have human data scientist skills and merge that with the generative AI capabilities, right? So human data scientists aren't going away. This is what I want to emphasize, right? Human data scientists are still essential because we have to be able to oversee the generative AI. We have to be able to frame the problem, understand the concepts of the basic data analysis, be the last, the humans are where the buck stops, right, in the world of generative AI. So we have to be still the ones that are trained and have the broad level understanding and the depth that is required in order to be able to correct and fix and refine the mistakes of the AI, right? At the same time, we provide the ethical oversight is this going the right way? Is this really aligned with morality and ethics and what we set out to do and our basic human responsibilities. And the benefits at the end of the day is that we get to automate some of our free time or automate the menial tasks in order to free up more of our time and human capital, right? So let's jump into the demo. I've been itching to get there. There was quite a bit of slides, so this is a good moment. Let's do a quick poll. Let's do a 1-minute poll. Alex, can we do the mid poll?
Yep, gonna launch it now.
There we go. We got question 2. So based on today's discussion, what do you believe is the most critical skill gap among stakeholders that needs addressing to effectively leverage generative AI? Technical understanding, ability to identify valuable use cases, governance and responsible AI expertise, cross-functional collaboration capabilities, or strategic planning for AI implementation. What do you all think? And we'll take 10 more seconds here. I'm going to stop sharing, switch to my demo. All right. I guess let's go ahead and stop the poll. All right, so I see the ability to identify valuable use cases as the top winner here. Yeah, this is definitely a super useful aspect, and one of the key challenge, the first sticking points that I see working with many different clients. Technical understanding is definitely there. That's something that we can definitely help you with, as well as training the muscle of how to identify high ROI use cases here at Ascendient. So excited to see that what you all are kind of sharing with us is exactly what we've been seeing with our students as well. And in fact, I think many of you have already taken courses with us or folks at your organization. All right, so let me stop sharing the poll, minimize that. All right, so I'm going to give an example, but while I give this example, if you have a use case or a domain or a problem that you want to solve with generative AI, type it into the chat. And let's see, let's see if we can look into some of those things with generative AI with some of my ideas. All right. So in the meantime, what I'm going to show you, let's cross our fingers. Sometimes ChatGPT, especially anytime I'm demoing something, likes to be sticky. But let's see how it goes. I've already tried this, so it should work, but let's go for it. So one of the things that we can do, classic data science task, right, is training and test set, being able to build a machine learning model, classic data science, right? So what we can do is we can say, I'd like you to leverage the CRISP DM methodology and create ML models as well as perform EDA of the data sets provided here, extract the relevant schema, and produce meaningful insights that can lead to business outcomes. This is actually a relatively synthesized and simple prompt, but one of the really cool things is that I think I already started to do this one a little bit. Oh no, this is from uploading it. Okay, so you can see that it uploads the model. It has all of the fields in the model, and this works obviously much better if the data set is small. So one of the things that you can do, right, is that you can use even a subset of your data set. Imagine you have a massive data set, but you can't post that on ChatGPT. Well, one of the things that you can do is you can create a synthetic data set or a smaller data set or a sample of the data set that's very small, that is anonymized, that you can upload, assuming that it fits with the governance policies of your organization. And what it'll do is that it'll start actually generating the code based on what it sees, right, in this data, and it's going to start analyzing that data, which for me is pretty cool. This, by the way, is only available for ChatGPT Plus subscribers. I'm not affiliated with ChatGPT in any way. I'm just letting you know that's how it works, but it's a super useful tool for data science because at least it builds a lot of the boilerplate code. And not only does it build the boilerplate code, it actually is going to run the code as well, which is useful, as you'll see, because there's no way it can create that graph without having actually run the code, right? Sorry, it keeps moving. So it creates a correlation matrix, which can be useful for feature engineering. It actually trains a linear regression model, which looks like it did pretty poorly. So one of the things that I can say, for example, is I can iterate with this, right? It looks like the model scores are really poor. In fact, they are negative. This means that the data likely needs to be cleaned and has some artifacts. Can you review the data with dot value counts, dot info? This is again because I know how to use pandas, right? And I know it's using pandas and other similar EDA methods in order to isolate data cleaning opportunities, right? Then clean the data and rerun the models. Consider feature engineering as well. Right. So this is, this really changes the game in terms of how I can basically just, use my mind and use my words in order to be able to write code, not to write code, but to be able to do data analysis, data cleaning, and the whole rest of it. Okay. So it's going to look into the EDA info. It's going to sum up the duplicated values. Here it's building some EDA to check the data cleaning. It's parsing the dates here, dropping duplicates. Right, so let's see what happens. It looks like it didn't find any duplicate rows. So this is one area, looks like, where I use a data set that kind of challenged, but you can see still that there's quite a bit of value in being able to build the boilerplate code for this data set and to be able to get insights. Let's create at least 5 visuals that are useful to gain insights about this data. Okay, so there we have it. Does anyone have any questions about how this works? Or what's going on here? Anyone? No? All right, moving along. One of the other things that I wanted to show you is one of the really exciting other tools that I saw recently. This is just the other day that I saw this come out. This is a tool called Llama Cloud based on Llama Index, which is kind of a competitor to LangChain. So it's in that realm of LangChain. It's an integration framework. I'm looking at the UI playground version, right? But one of the things that I did here was that I uploaded 10Ks, which are an annual financial document of a bunch of numbers. They're very long. I'll give you an example. Let's see if I can find one here. So here's an example. It's a massive document, 100-page document. It has a bunch of unstructured information, a lot of data in there, graphs, tables, etc. A huge mess, right? So what we can do is we can actually upload all of these things and we can run bulk extraction on these files. And what it's going to do is that it's going to look through the files, and based on the schema that I provided, which can be really useful in order to be able to create a JSON, which can be used for creating websites or to be able to create database entries, right? And this is especially relevant, let's say I'm in a financial company, this could be really useful, right? To be able to take a large document. But what I want you to see is not just see it in this use case, but see how it can be expanded and leveraged at your own organization, right? You can define a custom schema and basically have the generative AI model, the LLM, that's being used here. You can have it pull out the information that's in there. Okay, so let me see if I can. Let me show you an example of what it looks like. So this is an example of this. I'll share this for those of us who are interested in this. I'll share that link as well as this one. Oh, I sent to host and panelists. Whoops. Thanks, Alex. You caught me there. Send this one. I don't know why it shows my project, but that's fine too. I think you can navigate from there. You do need to sign up with an account, but it should be able to work. So so that's running, and I'll show you an example of what the results look like. So what the results look like is that it's going to pull out the extracted data, and it's going to have the filing info, financial highlights. So for data science purposes, this is really great, because one of the key tasks, again, is to be able to, we already have so much infrastructure in the data science world, the data engineering world, that deals with and works with structured data. The problem that we had is that we had a lot of unstructured data as well that couldn't really fit into those structures. So one of the key use cases, especially of generative AI in the world of data science, is that we can use generative AI to take all of our unstructured data and convert it into a type of structured form, to extract the key types of elements that are really useful, that if a human was reading it or a human expert was looking through, they would need to look at and extract and evaluate. Right. So, for example, this can then go into a database. It can be used even to create a CSV that could then be used with traditional ML models, for example. Right. So there's a lot of useful things that we can do with tools that perform structured data extraction. And in fact, one of the other things that we can do is that we can actually, even when we're working with generative AI, we can actually force the generative AI model to respond with a structured result, which is to say, to respond with a JSON. So this is called structured data outputs. Chunman asks, are these data extracted from PDF and converted to JSON data? Is it only able to do it via the Llama Cloud? No, there's a lot of tools that can actually do this, but it's just to show you what's possible, right? There's actually a lot of tools that can do this. But you can do this, and maybe one of the things that you're asking is, can you do this programmatically? Well, here is the notebook, which I believe I sent up here, right? So this notebook shows how you can actually access and programmatically do the same thing that I'm doing in the UI playground. The UI playground is just a little bit nicer to see, but you can see, for those of us who are, let's say, data nerds, you can see it extracts the filing info, and it defines the types of schema that we want to extract from the data. Does that answer your question, Chinman? Yeah. Okay. Cool. So, all right. And one last one. Here we go. So let's see what happened. So I can open up that one, and it's exactly like what I showed, right? This is the PDF, and then here is the structured data. So not the fanciest type of thing, but if you're familiar with data science, I'm sure you can appreciate how this is super useful from a data science, data engineering perspective. All right, one last one that we're going to do. This is a tool that's called Replit that I really like. This one really facilitates. This is a little bit more for structured software engineering development, but you can use it to also calculate things and do data analysis. So since we already did some data analysis by uploading a website, I wanted to show you something else that I've done. So for example, I want to create a website that will help me manage my marketing insights and customer profiles, because I know someone had mentioned that earlier, including insights about purchases and all audience related content, as well as campaign management. So I'm just thinking about things that related to marketing off the top of my head. But one of the cool nifty features this has is that I can say improve prompt, and then I click improve prompt, and then it's just gonna do that, and it's gonna expand this to a set of core features, almost like a use case of requirements. And when I click start building, it's actually gonna start writing the code, and it's gonna start writing a large amount of code. While that runs, I'm gonna open up a new tab. So it's creating a Streamlit dashboard, and it loads the website, right? So I think this is showing a different one. Let's see if it finished, but it's actually pretty cool because it can build an application that can be deployed. And if I look at the actual code that was generated, this is what's impressive to me. Where's the code? So it actually has, a ton of code that it's written. I'm trying to find where oh, here we go. So it's written the app, it's written the utils, pages, attached assets, Streamlit configuration. So it wrote all of this just for my prompt. So that's kind of what I want you to see, right? The massive amount of workflow improvement. Does that mean that you don't need humans anymore? Yes, you definitely are going to still need humans, but the idea is just to show that there's a lot that we can do with generative AI off the bat, running very quickly with kind of traditional or menial tasks. And then we can focus our abilities, our core kind of, let's say we can focus ourselves on, what are the types of core things that are really valuable, right? Trying to see if I can find the app. There we go. I think I closed it by accident. There we go, preview. So here we go. Can I take this full screen? So there we go. It built this app that, has images. It has, it built a basic website that can take the data preparation steps, feature engineering steps, and it created an entire dashboard. It did run into an error, but that's part of the gig. All right. So last thing. Where did my slides go? Gosh, here we go. All right. So there's a lot of case studies that are out there, right? Companies have been using these tools for anything from the medical domain, entertainment industry, e-commerce, you name it. There are use cases. So here's a link that's really useful to check out, 101 real world generative AI use cases, right? But we are going to remember, a list of information and resources. At the end of the day, to conclude, I want to emphasize that the future of data science integrates generative AI's efficiencies with essential human oversight, right? So it's about this human machine or human AI collaboration to accelerate business outcomes, to accelerate and fuel discovery and productivity. And we live in a really exciting age. I can't think of a more exciting age, especially in the realm of technology. We've never been in a more exciting phase in terms of technology, in my opinion, having been in the field of AI for the last 10 years, as well as data science. So if you're a data scientist, hold on to your hats. Don't worry about your job, but it does benefit you to learn about these tools, to learn how to use it in order to 10x your own productivity. And I think those are going to be the most valuable folks and teams in the fields. Right. So thank you all so much. Some reflection questions. Consider the aspects of generative AI that are relevant for you and how you might incorporate, data analysis and tools. Thank you all for your attention. I know we're running a little bit more overtime than I wanted for questions, but I do have time to take some questions. And we have a couple of things that Alex wants to share as well. And then after that, I will answer your question, Chunman.
Do we want to do the poll menu now, or do you want to wait until after my slide?
After your slide is good. Let's do your slide. Yeah.
Okay, great. All right. Really, really quickly, I won't take up too much of everyone's time here. I'm going to throw some links in the chat. Again, this is all going to be information that I'm going to share in a follow-up email to everyone that participated today. So thank you all so much for joining today. We do have some, as you can see, complimentary upcoming webinars that are coming up for the month of May. And we also have some, actually many GenAI courses, again, that Manu has helped develop with the help of all of our core instructors for AI. So I included some links to those as well. Again, there's going to be a resource document that Manu has created, which will include additional courses, some additional resources and directions on where to go for additional content. And then, as always, I wanted to include one more thing in this chat, importantly, that if there is any need for you or your team for dedicated webinars or programs, we are able to do that, an iteration of this program or webinar that you've seen today. We could run that internally for your organization. All you have to do is reach us at contact@ascendientlearning.com or fill out our contact us form here. And I included the link to that as well. So one more thing is that we will be sending out the post webinar survey link via Zoom. You'll be receiving that tomorrow. It's 24-hour notice since the start date of this session. And that will just be about 1 minute to 2 minutes of your time to fill out maybe 6 questions, just seeing what you liked here today and what you would like to see moving forward. But with that, I'm going to pass it back to you, Manu, for final thoughts.
Yeah, post your final questions in the chat. I have a couple more minutes. So I want to answer Chuman's question that said, do we still need the coding skill? What abilities or skills would be the most valuable for data analysts? Yeah, so what I believe is that I think that we're going to, all of us as data analysts, data scientists, software engineers, everyone in the technical fields, we're all going to have to evolve our own thinking, right? We might have in the past, for example, focused a lot on libraries and documentation and syntax, but now I can control P and print the entire documentation as a PDF, save the PDF, load it into Claude or ChatGPT or Gemini, and have it help me write code for whatever library, right? So what is required is to kind of be able to zoom out to almost a meta level to understand what are the functional aspects or requirements that are required, almost thinking more from a functional perspective, and at the same time having enough depth and skill in the coding and critical thinking to be able to correct when inevitably the AI blunders, right? Whenever inevitably there is a bug and the AI is running in loops and it doesn't know how to fix itself, right? So the coding skill is still vital. That's what I tell people and tell my students as well. It's still vital to understand how to code. And for example, if there's, I know a cousin of mine just is graduating college now, and yes, he asked me the same thing. And I said, yes, you still need the coding. It's good that you learn coding. It's good that you learn all the details in depth, but you're going to have to abstract some of those things and zoom out, but you still need that depth in order to be able to correct mistakes and to oversee what's happening. So I would say that it's still valuable to know coding, and the types of abilities and skills that will be most valuable for data analysts, certainly things like prompt engineering, being able to understand and think how to logically work through the entire software or AI process, and to understand the steps sufficiently that you could verbally coach someone how to do that, right? It's almost like you have an intern, right? Really, it's digital assistant. So how can you learn to be able to articulate what it is that you're thinking in your head, that you have up here in your noggin, and be able to articulate and verbalize it in a way that's simple and understandable and methodical? So that's, I think, a key skill that we're going to see in the coming years. Was there another skill? Okay, I think all of those were from Alex or Miles. Feel free to open up those links while we still have you here. Thank you all so much for joining. Really excited. Hope to do another one of these again soon, and look forward to seeing you all, some of you in my classes, and have a wild ride with generative AI and have fun. Enjoy.
Thank you so much, Munu, for hosting. I am going to launch just one more final poll for the team here. If you just wanted to take a second to answer that, I'll let it run for maybe about 60, 90 seconds while everyone's just taking a moment to download some of the information from the chat. But thank you all so much for joining, Manu. Thank you for hosting. It was a great session. Let me turn on my camera so I'm not just speaking like Oz. But thank you everyone for joining. And I'd love to see the engagement in the chat.
Awesome. Yeah, let us know also in the in this poll, but also the survey that goes out, how you found the webinar. We're always looking to improve our webinars, our communications, and how we can make these experiences better and more productive for you. Yeah. I'm
going to let it run for maybe another 20 seconds or so, and then I'll end the poll. But I appreciate everyone still engaging with us. I know we're a minute over time, but appreciate it.
Yeah. Thanks, folks.
I'm
I
gonna
had a
end.
plastic.
I'm gonna end the poll because I think we've got pretty much
Yeah.
that who are still with us. That did it. But I'll share the results, Manu, and again, I'll let everyone go. But thank you so much all for joining, and look forward to following up with everyone with all of the resources after the call.
Awesome. Thanks, folks. Take care. Have a good afternoon. Ciao.
Bye.
Over now.